Lesson 13.4, Measures of Variation. Going to continue our work with data, and we'll bring in a bunch of new terms and actually start playing with more data sets. So, range of data, it's greatest and least data points. What's the range of data here of all these monthly temperature data from Tampa, Florida? Well, I can just look at it and figure out the range, but the first thing we want to do when we're confronted with data is put it in order. And I would always put it in a spreadsheet if I had the chance, but for our purposes, I'll just write it down. This is a good way to do it, is cross out the data whenever you've put it in so you don't accidentally repeat. Good. So the range of the data would be from 69.8 to 90.2. And we would have to subtract that to get the range. So you should get 20.4. I believe this is in degrees Fahrenheit, even though we haven't really defined our units. So that's range. Now the question is, what's the mean of the data? Well, you'd have to add them all up. Divide by 12 because there's 12 data points. Put in your calculator, you would get 81.7. That's the average temperature, high temperature, in Tampa during the year. Now the median, there's 12 data points, so you go to the middle value. Got 1, 2, 3, 4, 5, 6, 7. Since it goes up to 12 data points, you go to the middle, which is here between 6 and 7. You would take 81.7 and 84.3 and just find the average between them, since there's an even number of data points and it doesn't work out perfectly. You get 83. And last but not least, what's the mode of the data? And that's the one that's repeated the most. If there's more than one, you would have to list them both, but in our case, it's just 90.2. And that's it. A little review for some of you, new stuff for others. So we want to talk about how spread out this data is. We call these measures of variation. We just actually showed centrality, and now we're going to say, how spread out is this data? We're going to find the quartiles. Q2 is just the median. So we count up 1, 2, 3, 4, 5, 6, 7. We have 15 points. Therefore, the 8th point, that's going to be the median. And we also call it Q2. Look at all the data that's left over. 1, 2, 3, 4, 5, 6, 7. Take the middle of that, which will be the 4th data. The 4th point, which is 4 in this case. And that's the first quartile. Q1. Same thing on this side. Take the 4th data point in. That's Q3, the 3rd quartile. We can also call these upper quartile or lower quartile. if we subtract the actual values, we get something called the interquartile range. And that is 13 minus 4. These are all data points that we can work with. For some reason, some of my points have up and vanished. Odd. So, that's a lot. Try and figure it out and see what you can do. Try it again. Find the median, or Q2, lower quartile, the upper quartile, and the interquartile range. You might want to pause the tape and try it. This data is not as clean and neat as the other one, so a little trickier. 13 data points. Seventh one gives me the median, also known as Q2. Now I've got 6, so I've got to go here and find the average. Which is 7.5. And that's Q1, the first quartile. That's 50. That's the third quartile. And the interquartile range, which we are going to just start calling IQR, would be 50 minus 7.5. 42.5. So, practice makes perfect. Not too much to worry about. Give it a shot. Last thing, what's an outlier? Generally speaking, an outlier, a data point that is off the charts. An example would be if I gave a test and the range of scores was from 76 to 100, but one person got like a 22. Clearly, an outlier is something that there's something wrong with that person, not so much the class because everybody else did okay. What's wrong with this one person? Did they have a bad day? Did they not understand the test? Did they not speak English? Who knows? We can actually define it, that is an outlier, as any data point that is 1.5 times the interquartile range smaller than Q1 or bigger than Q3. That, of course, is totally meaningless until I show you an example, so let's give it a shot. This is called a stem and leaf diagram. Put it in here to see who remembers. So this row would be the same as saying 12, 12, 17. That's the stem. That's the leaf. So we've got down here would be 40 and 46. And all the data points in between. So let's add them up. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's 20 data points. So now we need to find the median, which will be between 10 and 11. Which is nice because they're both the same, so I don't have to do any math. Median is 6. Since there's 10 data points below Q1, which is Q2, which is right in the middle, we take these And we say it has to be between 5 and 6, which is also nice. So that's Q1, 3. Same thing up here between 5 and 6, which we finally have to, pardon me, Q1 is 23, median is 26. I think I've done my math wrong. 1, 2, 3, 4. Yep, off by a little bit there. So Q3 is halfway between 30 and 31, which is just 30.5. So the interquartile range is 30.5 minus 23, 7.5, and 1.5 times 7.5 is 11.25. So we take Q1, subtract 11.25. In this case, that's 23. We get 11.75. Well, our lowest data point is actually 12, so there's no outliers on the bottom side. Now look at the top side. Take Q3, 30.5, and add 11.25. We get 41.75. And the highest data point is actually 46, so I'm going to put it up here as I'm running a little bit out of space. 46 is an outlier. It's greater than 1.5 the IQR way. There's a lot to work with here, but the math is very simple. Just a little bit of memorization, and make sure you understand how to find Q1, Q2, Q3. The rest follows along. Good luck.